Hello, let's get started. My name is Andy and welcome to my YouTube channel again. And today I'll introduce some homework problem in section 5.3, and which is the fundamental theorem of calculus. This part is quite tricky. I found the part in Method 25. And this is the same homework walkthrough video for my previous sections. My intention is to save your time while taking calculus, taking Method 25 at UW. I know college students have lots of commitment and the non-college is hard. So I want to save more time as possible. Just you have more time to do your homework for other class, to enjoy your life, and to do whatever you need to do outside classroom. And I want everyone to have a wonderful time at the University of Washington. I hope my videos are helpful. Well, my computer is automatically shut down unexpectedly, but now I'm back again. So for this question, I think the first 5 question 8 is easy because like g of x is just the area under the curve f of x. The only thing to make sure that the area under the curve, under the x-axis is just negative. So when just across x is equal to 9, to make sure to do some subtractions instead of addition here. Just make sure. Be careful of this sign here. What an open interval is g increasing? And recall to method 24. A function is increasing when the derivative rate is positive. And a g prime x is just f of x. So when fx is above the x-axis, it is positive, otherwise it is negative. So from 0 to 9, it is positive. What's the g have a maximum? And we just, in this case, we need to use like a local maximum or like the, and we can just tell like if the derivative is changing from positive to negative, did the local maximum occur? So x equal to 9, the local max occur. So just a magic graph here, you don't need to just one more complicated. So it's this one. Now for number 2, we just use the FDOC part 1. If like just a variable and the constant for here, variable on the top, constant is on the bottom. We just use the FDOC part 1 just to replace the t as x s. And the third one is it is a bit of a complicated because you use the chain rule because of the function on the top, the constant on the bottom. Just use a chain rule. And the number 4 is another complicated. You need to, because you see a constant and a function, you need to split up the integral, make sure the constant is on the top and constant because of 1 0, because this can be negative. So 1 0 is a function and the 2 minus 3x to a 0 is not an integral. For this, for 2 minus 3x on the top and the constant is at the bottom, so make sure to swap the bound by adding a negative sign to it. Number 5, just use the depth integral properties just to calculate the this definite integral, and this is FTOC part 2. For this, use a power rule. We rewrite it a fraction here is v5 over v4 and then 4y7 over v4. Use the power rule here for v to the 7. Just power rule and do it. This one, it looks too tricky. Use the U substitution, but you do not. When use the power rule is a to the b. For example, if you have a to the 10th and b to the c power, you can rewrite as, all you want to write is a to the 10th times a to the c. It's the same as a to the 10 plus c. So we write as eu times e to the 3, e to the cubic as a constant. So we move out the constant and there's no u sub needed. And the eu as a use, and the eu as an definite integral, and then that's it. But here, just to find the antiderivative of this function, we do like integral here. For this one, just the same as number 4, same process. And you want to go over this problem. This is f of x. So like a local minimum and local maximum is when the concavity changes. So if the first derivative change from positive to negative, then the local maximum occur. If the first derivative changes from negative to positive, then the local minimum occur. And then that's just read from graph here. It's like a local minimum. So the local maximum occur like x equal to 1, 8, local minimum at 4, 12. For 6, and this is absolute maximum. Concave downward. So it is when the second derivative is negative. For this problem, it needs some very special attention. So I will make a handwritten homework guide for this problem. So that is, I think, is all for section 5.3 homework problem. In next video, I will talk about section 5.4, which is net change. Thanks so much and have a great day.